Hi, this is David. We're going to start the webinar. Toby Rank from ECRI is going to walk us through the new products that we have available, including a great Combi, as well as some of the changes that have happened at ECRI Dunkirk, which is ECRI is the parent of Dunkirk. So here's Toby.
Great, thank you, David. Good morning. With us also is Dean Waldorf of NHEH today. As David said, as questions pop into your head, please type them in. We'll see to them right away as we see them. Also, if the audio gets dicey, please let us know that too. We're on speakerphone. We want to make sure that that you can hear us okay. So we're going to run through a slide deck here, talk about some new products. But first, one thing that is going on. I just want to talk a little bit about industry trends. This is a bar graph showing the U.S. gas-fired water boiler market for the last, 10 years, from 2004 to 2014. The top line shows total shipments of cast iron, copper, and condensing boilers across the top line. And then we break it down into the blue line representing cast iron, copper, conventionally fired boilers, non-condensing, and the red line represents condensing equipment. So we see that the lines are converging. Fewer conventionally fired pieces of equipment are sold annually, and many more condensing boilers each year are sold. The lines almost touched in 2010. That was the accumulation and the conclusion of federally funded tax credits that were helping offset some of the costs with high-efficiency equipment. The lines diverged, a couple weather events in there, Hurricane Sandy, in a highly densely populated hydronic area. Those sales really were generated by economic decisions. So cast iron and copper really ruled the day there. Condensing fell back a little bit. But here in 2014, they touched. 2015, the heating season that never was, condensing still managed to grow 3%, while the rest of conventionally fired equipment fell off double digits. So condensing is here to stay. We're sure that's happening in some of your markets. And it's a fast and fluid business from its sleepy days in the early 2000s and prior. In the modulating condensing market, we see there are a number of players. This slide just shows about 25 players. There are some 33 players in this congested market right now. That means for you a very feature-rich environment, but also price-competitive offerings. So there's a whole gamut of offerings, but the price is dropping on that equipment as we speak. Why is that? Why is that going on? All these manufacturers, European and Asian markets, are starting to mirror what our market is doing. Our market is mirroring what their market is doing in that the efficiency is growing so much. European and Asian markets support over 5 million boilers per year. Predominantly hydronic over there. We're here in the States. We are not. Non-condensing equipment is now prohibited in EU nations. Every new piece of equipment going in over there is a condensing appliance. And because of this mirroring their market, there are low entry barriers for these very large manufacturers that operate over here. So with this shift, the domestic players that have been king over here for over 100 years, it's going to be very difficult for them. They're going to be at a competitive disadvantage as this imbalance of production continues on. So consolidation is certain. This market and the unit throughput that we experience can't support these 30-plus manufacturers. So the consolidation will be on. And I don't know if you read last week, MTI was purchased by a large European player. Back in December, very interestingly, ECR International were purchased by a company called BDR Thermea. We went from 104 shareholders in December to 1 shareholder, and that is the BDR Thermea Foundation. They're self-generating in perpetuity. Sounds like some gobbledygook, but they are a foundation. They're not a conglomerate. They're not beholden to share price, shareholders, boards of trustees, things like that. It's a foundation, and is their objective that we continue on with our 88-year history. But just to enrich it and graduate from this shift from cast iron into competitively priced, but really forward-thinking solutions for this U.S. boiler market that is changing so quickly. ECR is now a family of the second largest manufacturer of hydronics in the world. We're a $2 billion company now, and that dwarfs any of the other boiler manufacturers that are domestically produced here. That includes Weil-McLain and Burnham and Peerless and ECR that we were. We were just over $1 million, and many of these companies are hover around the 100 to 200 million range. But we were a $135 million company. We operate in 70 countries, 14 manufacturing facilities, 6,500 employees. Most importantly, we now have 24 engineering teams, which bring diverse ideas, really a supermarket of ideas that we can go to and build new dynamic products from. And really exciting that the first product born of this relationship is a new price point, but very neat feature-rich combi offering called the DCB. Two SKUs Pierce Phelps has in stock. The DCC, it's a 150,000 BTU combi boiler. The heat side on the boiler provides 125,000, so it's for both space heating and domestic water. And then the DCB boiler is 125,000 BTU heat only. It does have the valve on it, the priority valve on it that comes with the combi, that we can incorporate the straight heat boiler then with an indirect fired water tank. A little more on that. Some of the features in it, we incorporate a thing called an AI control, artificially intelligent control, that we'll talk a little bit more about. Really cool thing. It's going to help save you time out in the field as you're diagnosing and setting up the equipment. Stainless steel components. It's a flat tube heat exchanger, the biggest on the market. Also a stainless steel premix burner on there. We have the ability to load match. On the heat side, we're 5.7 to 1 turn down ratio. On the domestic hot water side, we're 7 to 1 turn down ratio. It's a built-in 2-speed pump that bounces back and forth depending on flow and demand. We have some added protection of limit controls, certainly. But in lieu of a low water cutoff, we have a low water pressure sensor that will stop the boiler when it stops seeing below 6 pounds of pressure, assuming that it's running out of water. There's frost protection on it. Also, pump exercising and diverting valve exercising in the off cycle every 24 hours. On the domestic hot water combi side, a braze plate heat exchanger will be producing 3.5 gallons per minute at a 70-degree rise, which is comparable and the standard that we use in the industry. So again, it's something that is application sensitive. We're not going to put this boiler in a 5-bath home with 4 daughters and environment showers and things like that. It is an application. Probably think a single-family or multi-family application with individually metered, with 2 baths, laundry, and a kitchen sink. Competitively priced. I urge you to talk to your Pierce Phelps TM and look at the price on this unit. The objective of it was to be feature-rich, but with the competitive nature of the business, it needed to be a price point too, and we've achieved that. So we're very excited to roll that out. Also, with a 2-year free parts and labor warranty that will be covering our condensing platform. The AI control, we throw AI around a lot. Artificial intelligence, it's on everything. This is a little more than that. Rather than communicating simple system degrees and temperatures and what ambient temperature is the boiler seeing or what set point it's going for, the boiler is actually a self-commissioning unit. You don't need instruments to set this up. You don't have to have calibrated instruments. It's going to do it on its own. That's going to save you a lot of time on the job. As you're cleaning up your tools, the boiler is running through its self-commissioning. It's running through de-aeration first. That takes about 8 minutes. And then it lights off, and it's going to find its ignition point, its low fire and its high fire run, and then it's going to adjust accordingly. So it runs through all this. It's also going to recognize the fuel that it's firing. After that time, it's working off a lambda signal. It's going to recognize what fuel it is. It's going to know if it's natural gas or if it's LP. After the 12 to 15 minute commissioning period, it's either going to go to natural gas because it knows it is, or it's going to know that it's LP. It's going to ask you to confirm that it's LP. You'll hit confirm it yes, and the boiler will go into standby mode. Beyond that, it's going to continuously monitor itself every 9 seconds, and it will self-correct as things change through the course of the heating season, through the course of the boiler's life. It's going to adjust to low gas pressure. That happens at cold periods of time. You're going to get varying gas pressures in different areas. It's going to adjust its lambda signal and chase that CO2 range within the lambda signal to adjust to those conditions. Also, fan conditions change. If it experiences low CFM on the fan, it's going to try to adjust to that. If a kid has put a tennis ball in the makeup air duct at the termination, it's going to try to adjust to that. May not be able to, but this control is just a beautiful control, and it's been working very well in the units that we've moved. Dimensional data on the boiler: 17 3/4 wide, 30 inches high, 13 deep, 13.5 deep, weighs 100 pounds. This diagram shows the diverter valve in action, where we're showing a comfort heat call on the left. We have hot boiler water going out into the system, returning back. On a call for hot water, the diverter valve closes, diverts all hot boiler water either into the braze plate to divert all BTUs to generate domestic hot water, or again, we connect in lieu of the braze plate, we hook the boiler up to an indirect fired hot water heater. Diverter valve performs in the same fashion. When we're using an indirect heater, indirect water heater with the DCB 125 boiler, a simple sensor kit is purchased. The sensor rides in the dry well of the indirect tank and then just plugs into the terminal strip on the boiler, and then the boiler is going to operate as if it's a combi with the diverter valve rolling. This shows the bottom of the combi boiler. The H and the C connections are system supply and return. I'm sorry, letter I and letter C are system supply, system return. Letter G and letter D on the combi are hot water, domestic hot water supply, and cold water inlet. H is the condensing, the condensate removal system, a nice sophisticated drain trap that catches both condensate off the venting system and also condensate off the heat exchanger itself, and that's your drain point there to run off either into a filter or down to a drain. E is the gas connection, 3/4 inch gas inlet. This shows the straight heat boiler, same connections, I and C, system supply and return. Letter G is supplying hot water down to the indirect. Of course, J we wouldn't be utilizing. That would be hot water coming out of the indirect. And E would be the gas water connection, condensate removal off letter H. It shows the boiler with the front jacket panel off. A really nice jacket system that we manufacture in Dunkirk. Insulated, tested for LEED infiltration, that we have very little inside air that permeates through the jacket closure. That's a test standard that we had to sit by. The heat exchanger, as we said, a flat tube stainless steel heat exchanger. The modulating fan, the display with the display tray in the up position. The combustion air ports, we can test both incoming fresh air, and then we can also test outgoing combustion air should we need to verify the readings that the module is giving us. Pressure switch on the unit, reading pressure across 2 different points. The braze plate where it sits down below the heat exchanger, the diverter valve and diverter hydro block that sits inside the boiler that we manufacture and test in Utica, and the 2-speed pump. Our venting options with the boiler, we have 3 venting options. Top option is the option, probably the primary option, the vent pipe that we have in stock here at Pierce Phelps. It's coaxial system, outside aluminized steel vent pipe with an inner pipe of polypropylene, both a starter elbow, termination kit, vent lengths, and 45s. We also have a 2-pipe venting system that we can utilize, a 3-inch polypropylene, or we can also utilize 2-pipe venting system of CPVC vent pipe. On the right, we see the top of the boiler. The boiler comes with the coaxial hookup on it. Again, if we're utilizing it that way, we're ready to go. If you're utilizing a 2-pipe system, there are adapters that you use, and your combustion air would come in where that plate is shown on the right at the top of the boiler. Here are our vent runs. The total coax vent run that we can use about 32 feet. Where a 90-degree elbow equates to 3.25 feet. A 45 equates to 1.64 feet. If we're going to 2-pipe polypropylene, note that you must use both your vent pipe and your incoming pipe must be polypropylene. And we have a total, the air intake can't exceed just under 50 feet, and total air intake and exhaust cannot exceed together 196 feet. You see your friction on the elbows are a whole lot less. 90-degree elbows are 1.64 feet, 45-degree elbows 0.82 feet. And then CPVC, probably way down as we see these installations, we see very little CPVC utilized. Its cost is a little bit higher, so we see very little of that utilized, but you see your vent runs and maximums there. Near boiler piping. The boiler connections that we just showed a few slides back are straight thread. We cannot utilize our own fittings to that, so we provide near boiler piping hookup kits. So on the left is the supply pipe tree that provides. We also provide the pressure reducing, the pressure relief valve, and also the T and the PTA gauge that will mount in the supply piping. The system return piping, that also goes into the bottom of the boiler. On the Combi, then, we also provide the 2 domestic hot water connections. Those are all sweat connections at the bottom that you'll utilize then. We also provide a gas shutoff with a 3/4 thread on the bottom. So again, don't go with your own fittings on the bottom of the boiler. Utilize the near boiler piping components that we provide with the boiler. We want to utilize primary, secondary piping with the boiler, so we show the boiler mounted with the near boiler piping on it. We'll simply run our piping over into the system piping where we're tying its return and supply together with 12-inch maximum separation on the T's here. Oversimplified drawing here, we show air separation, circulating pump, and then the components that should hang under that separator. That air separator is a really good one to use. We would prefer on these smaller, low-mass modulating condensing boilers, you're not utilizing the cast iron air scoop that lives on most cast iron boiler applications here in the States. We want to graduate up to this micro air bubble air separator. We're rolling through these slides pretty fast, so if you do have questions, please type them in, and we'll try to get them answered. So this is kind of a review page. Just shows the DCB and some of its features and benefits. The 2-year parts and labor, we'll get to that. We have a slide dedicated to that as we run through. One cool thing with this boiler launch that we're doing is a thing called a Dunkirk DCB live fire cart. We actually have the boiler mounted on a hand truck, and it enables us to go around to contractor shops, distributor meetings, association meetings, lunch and learns. We have an LP tank that hooks up to the bottom of it. All we need is a power source and a little bit of water that we can run through, and then we can actually demonstrate how easy the boiler is to operate and show the self-commissioning aspect of it. So we encourage you to talk to your contractors. If we have contractors on, we'd love to come by your shop and do a little, half an hour, 40-minute dog and pony. It's really an effective way to really see the boiler operate live. So we hope to see your sign-ups, and stay tuned. We are scheduling branch meetings, encounter days, things like that, but this boiler will be there. It'll be the star of the show. So shifting on the condensing platform from the DCB, we want to talk about the VLT boiler, the boiler that's been in the line for some time. Want to hit on its features. We've had some changes on it, most importantly there at the bottom, but 95% AFU. This boiler has the exchanger that we designed, US-made, self-cleaning, vertical water tube heat exchanger, self-cleaning. The VLT has built-in primary, secondary piping and a built-in low water cutoff. So added labor savings, added value, time savings, component purchase values. 6 models available, 50, 75, 100, 150, 200, and 299,000 BTU inputs. Enjoys a 5-to-1 turn-down ratio. Its exchanger is a 15-year heat exchanger. We're overlaying the free 2-year parts and labor on that. So again, the price point on this, we showed that slide that had all those manufacturers in it. This market is very competitive. So we've adjusted this boiler, the VLT, is at or just above comparable condensing models that do not have built-in primary, secondary piping and low water cutoff. They're basically getting it for free, and they're going to be saving about 4 to 8 hours of time on the job. So we equate that to over $600 of added value. So again, encourage you to price this boiler and see where that falls with any brand you're using now. This shows the built-in primary secondary aspect, circled on the VLT boiler hooked up to the system. Everything that's going on on that second circle to the right is going on inside our boiler. Any other modulating condensing boiler, that componentry and that near boiler piping has to be hooked into the main system. So the VLT is coming with that, and it's when you price this boiler, we're there. So again, there's a lot of value in this boiler. The low water cutoff, probe type low water cutoff, is actually seeing the water level in the boiler. It has a test button on it for inspectors to test it. It's mounted inside the boiler near boiler piping. Condensate and flue collector sits in the bottom of the boiler, polypropylene, impervious to the acids that are contained in the condensate. A lot of condensate flue collectors on competitive models are actually stainless or aluminum, and those are not impervious to the acids. So if the condensate puddles and pools in those, you may see some pitting over time and failure. So our collector is going to last probably a lifetime of seeing condensate removal. Again, here's a fab, excuse me, a fab sheet on the VLT. Shows the water tube heat exchanger on the bottom of the page there. That's our water tube 7/8 ID diameter. That's seeing full flow, about a ½ pound pressure drop through our exchanger versus a competitive fire tube exchanger. So then we move on from the VLT to the VX. It's the VLT's little brother. 95% AFU, still has the same US-made ECR design vertical laser tube 316 heat exchanger. So enjoys the same heat exchanger, all the benefits and value of that. However, it is built less the primary secondary boiler piping and without the low water cutoff. Why would we do that? Why would we have another boiler? Modulating condensing boilers are 15 to 18 years old now when we start seeing a pretty substantial replacement market. You're not going to need to go out and sell a VLT boiler when we're replacing an existing modulating condensing boiler because the primary, secondary, near boiler piping and pumping is already set up. So we really just need a boiler that's going to hook up to that existing primary, secondary loop. So again, we have a price point on this boiler. We've right priced this boiler along with the VLT. Encourage you to match this price against your existing price. Look at it versus the VLT. Substantial. We're coming well below what competitive offerings are now. So if you're well versed on doing your own primary, secondary, or you're doing a replacement boiler, the VX boiler brings a lot of value to the party. There's the VX fab sheet. This is all available on, we're recording this, so this will be available to you to review again. Hear my voice all over again. So, our condensing platform is all wall mount. Sometimes you don't have a wall to hang your equipment on. You have to either fabricate a 2x4 wall, put strut up, plywood, things like that. We also offer a floor stand. It's powder coated. It's beautiful. It ships knocked down, so it ships in a carton that can get to the job site. Quick assembly, and that'll take virtually the whole condensing platform line and hang on that at a very competitive price. So a little more about this 2-year parts and labor warranty. We talked about the VLT and the VX with a 15-year exchanger warranty. The DCB's exchanger warranty is 10 years. However, they all will carry this 2-year free parts and labor warranty. Imperative that there's kind of a 2-step process. First, the installation has to be registered with us with the boiler serial number, and then the installing contractor also needs to be enrolled to service the equipment. That is all achieved online through our site, dunkirkboilers.com. There's a warranty section on there to go in that, 1, the homeowner can register the boiler. 2, preferably the installing contractor can register the boiler, but he can also enroll there at that point. So this is a whole lot easier than filling out reams of paperwork, but it's a critical component of this free year parts and labor. Homeowners see this, it closes the deal at the table. The boiler doesn't get registered, or the boiler doesn't get registered, it falls between the cracks, and then that boiler is really not covered. So it's best, that's why it's best that the contractor does it. The contractor is not enrolled to service the equipment. Our carrying provider, Trinity, can find a local guy to cover it. But first steps are to register the new install and make sure that that's done. So we shift from kind of the top of what our market is, the modulating condensing platform and all the buzz that's going around there. We know there's a reality. There's still plenty of cast iron being sold. The cast iron, or the modulating condensing platform is for the most part, I lost my train of thought with that slide jump, but you know, that's a growing segment. But yeah, the modulating condensing segment is mostly gas-fired. You see a little bit of oil-fired condensing equipment, but steam boilers, oil-fired boilers, and then some gas boilers still remain to be cast iron. So there's that market. That market exists. It's not going away, and we're not outlawed from selling them, certainly. So we have a nice, robust line of certainly Dunkirk cast iron boilers, but with the price point aspect of where the equipment is going, that is a competitive side of the business too. So the 15B boiler, the 16, the Keystone boiler are a nice robust offering of cast iron boilers. Durable cast iron, bulletproof, built for strength, system longevity. Some of the systems that we have here, standing radiation, high water volume, a lot of scale, sediment in the system. Cast iron boilers are forgiving of those types of systems. We seal our cast iron boilers with cast iron push nipples. The same expansion and contraction rate, very reliable way to seal our cast iron sections. No gaskets, no dissimilar metals. So it's a nice, robust way to seal the equipment. The 15B boiler itself, as well as the 16 steam boiler, have a very low profile. Integral draft diverters, so we don't need to put the mushroom cap on top of the boiler that increases our profile, then we then have to tie it into a chimney. With the advent of some of the changes that were made due to Sandy, we're seeing a lot more equipment having to be put up on blocks. That moves the whole profile of the system up about 24 inches. If you have a chimney crock that's set already, and then you put a boiler in that requires one of these high-profile flute gas diverter, it's going to require the contractor to break another hole into the chimney. So with the 15B and the 16, the low profile, you will have chimney access very easily. Beyond that, we have a nice robust side of oil-fired equipment as well as oil-fired steam equipment. So it's, we have a full catalog, we have a full inventory, we are ready for the winter to come, having not enjoyed one last winter. So we wish you a very good heating season. We thank you for your attendance today. We will be around to all the local Pierce Phelps branches with the new DCB. We're very excited about that. With the changes that have happened at ECR, we have a full pipeline of equipment on the horizon. We're going to be seeing higher boiler capacities, higher turn-down ratios, higher capacity combis, communicating controls that are going to be on board our new modulating platform here in the next 2 years. So it's really an exciting time to be in the boiler industry, and we hope you'll take the ride with us. So again, thank you very much for your attendance. We will follow up here with you and look forward to seeing you soon.